questions 21 through 25 on the 2014 grade 10 AMC 10B. Trapezoid ABCD has parallel sides AB of length 33 and length 21. The other two sides are 10 and 14. The angles at A and B are acute. What is the length of the shorter diagonal ABCD? Let's draw a trapezoid that kind of looks like what they're talking about. So perhaps something like this. And what we'll do is we'll try our best to figure out the diagonal, the shorter one. Okay, so let's label this. This is going to be 21. This whole thing down here is 33. This is 10 and this is 14. Now I'm going to label this x, the distance from there to there, and this I will label y, the distance from there to there. And from here to here is 21, since that becomes a rectangle. Okay, so a few things that we know is that x plus 21 plus y is 33, and therefore x plus y is equal to 12. So that's the first thing that we know. And then using Pythagoras, since I've drawn these 90 degrees, we know that if this is, say, the height, we know that x squared plus h squared is equal to 10 squared. But we also know from the other triangle that 8 squared plus y squared is equal to 14 squared. So isolating for h squared is 100 minus x squared over here. And over here, h squared is going to be 196 minus y squared. And then set them equal to each other. So 100 minus x squared is equal to 196 minus y squared. Put everything on one side, and that gives me 96. Factor this guy here, and when you do, you get y minus x and y plus x. Well, y plus x is 12. So substitute in 12 there, and when you do, you get that y minus x is 96 divided by 12, which is 8. And therefore, y is equal to 8 plus x. Substitute that back into here, and when you do, you get x plus y. Well, y is 8 plus x is equal to 12, so that means 2x is equal to 4, x is equal to 2. So this guy is 2, and therefore, since x is 2 and x plus y is 12, y is equal to 10. Okay, so all that hard work to get 2 and 10. Okay, well, what do we do now? Well, we need to figure out the longest diagonal, right? Well, which one do you think is the longest diagonal? From here to here or from here to here? Well, obviously, it's going to be the diagonal that involves the shortest sides. So it's going to be this guy right here, that diagonal. And that diagonal I can easily figure out with Pythagoras. It's going to be this squared. So that's 2 plus 21. Be careful. So that's 23 squared plus h squared is going to be that diagonal square, d for diagonal. Well, 23 squared, well, that's great, but what's h? I've got to figure out h, right? I haven't done that yet. Okay, no problem, just use that. h squared is 100 minus x squared. 100 minus x squared. X is 2, so it's 100 minus 4, and that's d squared. So 23 squared plus 96, and that's 625, is d squared. And then d works out very nicely to 25. So number 21, the answer is B. Eight semicircles lined the inside of a square with side length 2 as shown. What is the radius of the circle tangent to all of these semicircles? There's a short way and a long way. Of course, I will show you the short way since that is recommended. First, draw a little bit of a diagram here, not too much. I'm going to draw one line from the center of that big circle to the top like that. And then I'm going to draw another line from the center of that semicircle to the center of that circle. And it passes through this tangent point right here. And that's it. That's the diagram I'm going to use. So this is obviously a right angle here. And this length is a half, right? Because they told me the whole side is 2. So that means the diameter is 1. So that, since that's the radius of that semicircle, it's a half. The distance from here to here is 1 because it's basically half of the total distance, and the total distance is 2. So that's got to be 1. And then the distance from here to here, well, from here to here is the radius of that circle, and I don't know what it is, so I'll just call it r. But the distance from there to there is obviously the radius of that semicircle, which is a half. All right, so that's it. I've got a Pythagorean relationship. 1/2 squared plus 1 squared is equal to r plus a half squared. So this becomes 1/4 plus 1 is equal to r plus a half squared. And then 1/4 plus 1 is 5/4. And if you take the square root, I should say, it will become √5/2 is equal to r plus a half. And therefore r would be √5/2 minus a half. And that's it. Very nice, quick way of doing it. And that matches answer choice B for number 22. A sphere is inscribed in a truncated right circular cone as shown. The volume of the truncated cone is twice that of the sphere. What is the ratio of the radius of the bottom base of the truncated cone to the radius of the top base of the truncated cone? Here is a diagram. We'll try to keep this as simple as possible. So let's label a few things. This will be my radius of that top part, and this is the radius of the bottom part, so big R. And then the radius of the sphere, I will just call S. So from here to here is S, and similarly from here to here is also S. Now, the height of that top part I will call small h, and then of course the height of the big part will be big H. So we'll just label a big H right here, big H. And I think that should be it for our labeling for now. So now, very quickly, we can do a few relationships on the side here. Using similar triangles, h over r, this h over this r, is the same as this over that. And that would basically be the equivalent of writing 2s over r minus r, big R minus small r. The next relationship is that the big height from top to bottom is h, and that is equivalent to 2s plus small h. Okay? And then the next relationship we get using Pythagoras. And the Pythagorean theorem is going to be used on this triangle right here. But before I do that, I have to explain one thing. And that is that if I draw a tangent point from the center to that point, which is where that sphere touches the cone, that, of course, is going to give us a very helpful clue that the distance from here to here is the same as the distance from here to here. And the reason is because when you take a point and from that point draw tangents to two parts of the circle, those lines will be equivalent in length. So if that's r there, this has got to be r also from here to here. And in a very similar way, since you're taking a point from here and drawing tangents to the circle there and there, those two are going to be equal. So if this is r from here to here, this is going to be r as well from there to there, small r. Okay, so that helps us, and now we can proceed with Pythagoras on that triangle. So when we do, we get 2s squared plus r minus r squared is equal to the hypotenuse, which is r plus r squared, like that. So let's simplify. This is going to be 4s squared plus r squared minus 2rr plus r squared. This is going to be r squared plus 2rr plus 2r squared. A lot of stuff cancels here. And then the only thing we're left with is 4rr, and the 4's cancel, and giving us just s squared equals rr, and then s is going to be the square root of big R times small r. So those are some very important relationships that we are going to use in this question. All right, now let's proceed with the question based on what they told me in the STEM, which is that when you take the area of that truncated part, which is just this part here, right there, it's equal to twice the volume of the cone. So that truncated part is 1/3 pi big R squared times big H minus the top part there. I've got to subtract that. So that's going to be 1/3 pi small r squared H. And that is equal to 2 times the volume of the sphere, which is 2 times 4/3 pi s to the power of 3. All right, that's standard application of the formulas. A lot of stuff cancels here. The pi's cancel, the 1/3s cancel, and all you're left with is r squared H minus r squared H, small version, and then 8s to the power of 3. Okay? And now at this point, we have to start substituting these guys here. And then eventually we're going to substitute in that one. So the first thing is for this h right here. We've got to get rid of that. So r squared, h is 2s plus small h right there. And then minus r squared, but the small h, I'm going to put in this part here. So that is 2sr over r minus r. And that's all equal to 8s cubed. Okay, so far so good, right? Now we've got to simplify this, meaning we have to once again put in this value for h. So that becomes r squared 2s plus h, which is 2s times r over r minus r, like that. And we have minus r squared, all of that. And then we put this under a common denominator, and when you do, you basically get that this is going to be r squared times 2s times r minus r plus 2sr all over r minus r. And then the other one, we can just multiply it out, and that's going to give us 2sr cubed over r minus r is all equal to 8s to the power of 3. Okay, so now when we multiply this out, we get r squared 2sr minus 2s small r plus 2s small r over r minus r. And the rest is the same. Well, a couple things cancel here, these two guys, that's good. So now all we are left with is 2sr cubed minus 2s small r cubed all over r minus r is equal to 8s cubed. So making some pretty good progress here. We can cancel out quite a few things now. We can cancel a 2 from both sides, and we can cancel an s from both sides. So on the other side, we just left with 4s squared, like that. And then this leaves us with just big R squared to the power of 3 minus r to the power of 3 all over r minus r. So now this is all we are left with, this guy right here. Now the top factors, so we have big R minus r times r squared plus big R plus r squared all over big R minus r, and that is 4s squared. So that cancels with that, and all we're left with is just r squared plus r plus r squared is equal to 4s squared. Okay, great. And finally, we get to use this right here. That's why I kept it in the screen. So we can put in r without the square root because we're squaring it. So it'd just be like this. All right, now let's put everything on one side. And finally, we get r squared minus 3 big R plus r squared is equal to 0. Great. But unfortunately, we've got to use a quadratic to solve that. But that shouldn't be too big of a deal. So let's use a quadratic. That means r is equal to minus b. In this case, it's minus 3 small r plus or minus the square root of b squared, which is minus 3r squared minus 4ac, which is r squared, all over 2a. Well, that means this is going to be 3r plus or minus 9r squared minus 4r squared under the square root sign over 2. So r is 3r plus or minus, that looks like 5r squared, like that, over 2. So that means that r is going to be 3r, and I'm going to use the positive one because obviously r represents a radius, so I don't want negative answers. So this is going to be root 5r over 2. Factor out an r, and that's going to give me 3 plus root 5 over 2, like that. And then finally, we get our ratio by just putting the small r in the denominator, and on this side we get 3 plus root 5 over 2. And this is what they were asking for. So 3 plus root 5 over 2 is the answer, and that means number 23, the correct choice is E. The numbers 1, 2, 3, 4, 5 are to be arranged in a circle. An arrangement is bad if it is not true that for every n from 1 to 15, one can find a subset of the numbers that appear consecutively on the circle that sum to n. Arrangements that differ only by a rotation or a reflection are considered the same. How many different bad arrangements are there? First, let's explain this question before we dive right into it. We'll explain it with an example. So let's say I put the numbers 1, 2, 3, 4, and 5 around a circle. And I say to you, I want you to figure out how to get a sum of 1, 2, 3, 4, and 5. And when you do, let's circle it. Okay, so how do I get a sum of 1? Well, it's easy. Just choose 1. There, you're done. How do I get a sum of 2? Just circle 2. You're done. Similarly, 3, 4, and 5 are easy. Just circle that one number. Now, how do I get a sum of 15? No matter what order these numbers are in, all I have to do is just choose all of them. And when I do, I will get a sum of 15. No matter what order these numbers are in, all I have to do is choose all of them except the 1. And as you can see, they're consecutive, and they will add up to 14. And very similarly, no matter what order these numbers are in, if I circle all of them except the 2, like that, they will add up to 13. If I circle all of them except the 3, they will add up to 12. And if I circle all of them except the 4, they will add up to 11. And finally, if I circle all of them except the 5, they will add up to 10. So all of those will be possible no matter what the arrangement is in terms of how I draw the numbers. So the only ones we really need to concentrate on are 6, 7, 8, and 9. Okay, so let's do that. So 6, 7, 8, and squeeze one in more in here. Okay, so my goal now is to figure out how to arrange numbers 1, 2, 3, 4, 5 so that I do not get a 6. Okay, so I do not want a 6. So how can I do that? Yeah, do a little bit of experimentation basically. If I put the 2 here, a 1 here, a 4 here, a 3 here, and a 5 here, There's no way for me to get a 6 now. If I add those two, it'll be 7. If I add those two, it'll be 5, and so on, right? If I had put the 5 and 1 beside each other, then I'd be able to get a 6. Or if I had put the 1, 2, and 3 consecutive, 1, 2, and 3 like that, then I'd be able to get a 6. But I purposely did it in a way so that the 1, 2, and 3 are not consecutive and the 5 and 1 are not side by side. So this gives me no 6. So that's one way of creating this bad arrangement, because it's not true that for every n from 1 to 15, one can find a subset of numbers that appear consecutively on the circle to sum to n. Okay, great. I got 1. So that's pretty good. Now let's try no 7. Okay. Again, you fiddle around with this, and when you do, you get this arrangement. 2, 4, 5, 3, 1, and 3. If you arrange them like that, 2, 4, 5, 1, and 3, there's no way of adding up to 7. If the 2 and the 5 were side by side, you would get a 7, right? So I purposely made sure that the 2 and the 5 are not side by side. And very similarly, I made sure that the 1, the 2, and the 4 are not consecutive like that, because that would add up to 7. So that's how I arranged this. Okay, now I got 2 of them, so I'm up to here. Now we have to concentrate on no 8. Well, no 8, I can do that as follows. 1, 3, 2, 4, 5. Like that. That makes me not have an 8. Now you say, okay, well, we're up to 3, but here's the thing. Arrangements that differ only by rotation or reflection are considered the same. This one that I just drew, 1, 3, 2, 4, 5, is the same as this one. This is also 1, 3, 2, 4, 5. It's just rotated. So this is not unique. Not unique. It's the same. Okay, so I really have only 2 unique so far. Unique here and unique here. Okay, so let's see the last one. No 9. And again, after you experiment and fiddle around, you will be able to make one as follows. 2, 1, 4, 3, and 5. You will see when the numbers are arranged like that, there's no way to get a 9. Well, 1, 4, 3, 5, 2 is the same as this one. 1, 4, 3, 5, 2. So again, not unique. So how many unique did I get? Only 2. And therefore the answer to number 24 is B. In a small pond, there are 11 lily pads in a row, labeled 0 through 10. A frog is sitting on pad 1. When the frog is on pad n, where n is greater than 0 but less than 10, it will jump to pad n minus 1 with probability n over 10 and to pad n plus 1 with probability 1 over n over 10. Each jump is independent of the previous jumps. If the frog reaches pad 0, it will be eaten by a patiently waiting snake. If the frog reaches pad 10, it will exit the pond, never to return. What is the probability that the frog will escape being eaten by the snake? So we have pad 0, 1, 2, all the way up until pad 10. Now, a really helpful thing to realize in this question is that the frog starts here, right, at pad number 1. But if the frog reaches pad 5, then, because of the symmetry of this diagram, it has half the probability, 50% of going all the way here, and 50% probability of going there. So that's very important. So by symmetry, if the frog reaches pad 5, the probability is of half of going to pad 10, and the probability is 1/2 of going to pad 0, where the snake is. So we are interested in him obviously going away and escaping. So before we jump right in, let's create just a few examples of what can happen. So he starts here, and based entirely on the question, the stem, and the information, if he is going to go here, that happens with a probability of 9 over 10. And if he goes here, it happens with the probability of 1 over 10. That's entirely based on the question. If we keep going, and we are now here, pad 2, the probability of going back to pad 1 would be 2 over 10, and the probability of going to pad 3 would be 8 over 10. If we are at pad 3, the probability of going to pad 2 would be 3 over 10, and the probability of going to pad 4 is 7 over 10. And then similarly, if you're at pad 4, the probability of going to pad 3 would be 4 over 10, and the probability of going to pad 5 would be 6 over 10. All right, so now we have to combine all of these. So if you're at pad 1, and let's give a definition first. Let pk represent the probability that the frog escapes if it is on pad k. So, based on that definition, P1 is the equivalent of 9 over 10 P2, right? Because he was here, and in order for him to go there, the probability is 9 over 10. And very similarly, P2 is going to be calculated as follows. First, we have to figure out 2 over 10 P1, right? 2 over 10 P1 plus 8 over 10 P3. There we go. And then P3 is going to be 3 over 10 P2, right? 3 over 10 P2 plus 7 over 10 P4. And then P4, that is going to be 4 over 10 P3, right? 4 over 10 P3 plus 6 over 10 P5. And then finally P5, well, we get that one for free since we had established that the probability of escaping when you reach pad number 5 is a half. Because of the symmetry of the diagram, it's a half to go there and a half to go there to 0. So P5 is actually a half. So now what we have here basically is a system of equations. We have 4 variables, P1, P2, P3, P4, and we have 4 equations. We actually have 5, but the 5th one just gives me a direct value for P5. So you solve these system of equations, and you guys know how to do that. And when you do, solving this, you get P1 equal to 63 over 146. So that basically means that because he starts off on pad number 1, 63 over 146 is the probability that the frog will escape. And therefore, number 25, the answer is C.